Welcome to my ITS Networking Cert Review video series. In this lesson, we're going to be going over the first domain of the IT Specialist Networking Industry Certification. The first subdomain is called Define Network Concepts. In this domain, you should be able to define network concepts such as internet, intranet, extranet, client-server network, peer-to-peer network, transmission types such as unicast, multicast, and broadcast, as well as network devices including IoT, or also known as Internet of Things. Before we delve into network concepts, I want to real quick emphasize the importance of networks. More and more, we have utilized networks in our daily lives for both our personal and our professional lives. We've come to rely on them. We want to make sure they're available. If we don't have internet access, it doesn't seem like we're normal because we can't access people, we can't access our products, we can't be globally connected. Our society is dependent on it. It allows us to make our lives easier. In fact, networks are the foundation of modern communication and information sharing. Before the internet, you used to have to call somebody up on the phone if they were even home and connect to them. You used to have to go out and take a trip to see somebody. Now, what networks allow us to do is we can send an email, we can send a text message, we can send a direct message through social media, we can even FaceTime or video chat with somebody from across the globe. That's because of networks. It's because we're connected globally across a bunch of different network devices. So it allows us to do that. Some organizations depend on this as well. Networks also allow us to access and share information and resources easily. Like right now, I'm submitting this information on YouTube for anyone to access this information. In school, I publish my courses on Canvas, so that way you don't have to rely on storing the papers and keeping the papers. Everything's available digitally. It's stored on a central server that I can access from anywhere. If you have to do some sort of research paper, you can quickly go into a Google search and look up a particular topic rather than have to go to the library and check out books. It just makes that whole process easier. We can also collaborate on projects and work remotely. So collaborating on projects meaning we don't have to be in the same room anymore to work on a project. We could be in completely different places in a city, in completely different places in a building. We can even be in completely different places around the globe for us to be able to collaborate on projects. And it allows people to work remotely, work from home. So if for some reason they can't go into the office, they can go in and do, if their work allows, to do their work from home. We can also use networks to enjoy entertainment and educational content online as well. So now a lot of people have moved away from cable TV and have used streaming apps to get their entertainment. We can watch sports on the internet now. We can even use products like YouTube or TestOut to view educational content online from anywhere. We have a device in our pocket, like a smartphone, that can access this information, or we can just plug in a computer or open a tablet and view that information as long as we have access to our Wi-Fi and to the internet. So that provides that benefit as well. We can also conduct business and commerce efficiently. More and more businesses have moved online, and being online is part of their business plan. Some businesses don't even have an office per se. They work entirely remote, relying on people all over the globe to do various tasks. We do a lot of online shopping through Amazon and other types of retailers, and moved away from a lot of the brick and mortar physical stores. So the networks allow us to do that, and we have to focus a lot on network security to make sure the critical information we're putting into these networks is secure, and we're finding ways to secure that from threat actors or anyone who wants to do us harm or steal that information. We can also manage and control smart devices in our homes. If you asked me 25 years ago and and told me that I could control my washer and dryer from home or from somewhere else other than home using my smartphone, I would thought you're crazy. But you can now. I can talk to my phone and have it start my Roomba and do my vacuuming in my house. You can have it preheat an oven. You can have your phone stream video to a completely different device in their house. This all happens using networks, allowing our devices to connect together to do different tasks. So now let's define what is internet. So by definition, the internet is the worldwide network of interconnected computer networks ranging from local to global in scope, comprising of private networks, public networks, academic networks, business networks, and government networks. So basically anything that can connect to that overall WAN that everything else is connected to is part of the internet. The internet is connected by various electronic, wireless, and optical networking technologies. It allows it to work, to function properly. A lot of those networks have to be identified with specific addresses for you to connect to, and you have to specifically set resources to be functioning on the internet that anyone else can access. One of the big keywords right now in the IT world is the cloud. The cloud is essentially another word for the internet. When we can store things or have the cloud do different things, that just means we use the powers on the internet to do that. So anything that is public facing that you want people to access from the public side is going to be accessible through the internet. Now that we've mentioned what internet is, that public network that anyone can connect to, let's talk about the opposite of that. We have the intranet. Sounds a little different. An intranet is a private network accessible only to an organization's users. So what this means is this is an area that only people in an organization can access. It's like a private network. Generally, it's separated by some sort of firewall that can only allow specific organizations to access this. So a lot of the times this would be something like an area where we do collaborations, that we don't want the information leaking out to the internet. We might want to store our corporate directories, like those directories that have the maybe the CEO or CFO, maybe their contact information, their direct contact information, as well as who they are. Maybe we don't want that out onto the internet, so we can store that on our intranet. Sales and customer relationship management tools, information that we wouldn't want to publicize, we could put on the intranet. Product management, as well as benefits and payroll. A lot of the times when you work for an organization, there's an actual area. A lot of the times it's in a website called Microsoft SharePoint, where you're able to log into the intranet and access your pay stubs and your benefit information, so that way you can access that at your convenience without it being posted on the internet. So it's essentially like the company's own intranet, but it's not accessible to the public. It's only accessible while you are on the private network. So I have covered the internet, which is our public network that anyone can access. We have our intranet, which is the organization's network or your private network that only you can access while you're on that network. Everyone else on the internet can't access that. Now we're going to talk about what is extranet. Extranet is a controlled private network that allows access to partners, vendors, and suppliers, or an authorized set of customers. So think of an extranet as an intranet, but you're allowing certain people to access it. There's a separate area that only partners, vendors, and suppliers can access to. So it's generally restricted. It requires them to authenticate or prove who they are, who they say they are. So some examples of this could be supply chain management. So looking at order details, tracking shipments, etc. When you log into your Amazon account and look to see what the tracking number is and being able to see all that information, that's part of an extranet. That's in the customer portal. It's also where you can access order history and all that information. That's not publicized on the internet. I can't go into your Amazon account and see what you've ordered because I don't have the authorization to do that or the authentication to do that. I don't have your username and password, and I don't have the rights to access it anyway. So that's part of an extranet. That's private between you as the customer as well as the overall organization. That's an extranet. If you are working jointly with another organization on particular projects or sharing documents between the two. For example, if you were in the video game industry and you're working with a bunch of different studios on something, you only want to communicate with those specific studios, those specific organizations, so you set up an extranet. You don't want it just on your network, but you also don't want it on the internet, so instead it's a controlled intranet. It's allowing partners, vendors, or suppliers, or the authorized set of customers to access this information. So when we're talking about networks, there's really two big types of networks. The first type of network is called the client-server network, and a lot of the times this is what you're going to encounter when working with networks. A client-server network consists of two distinct types of devices. You have the clients. These are user devices that request resources from servers, such as a laptop or a smartphone or a computer. Think of these as your customers placing orders. You want to access something. Servers, on the other hand, are powerful computers that store and manage resources and respond to client requests. And these are examples of these are like web servers and database servers. Their whole purpose is to provide you with the resources. And because they have lots of clients accessing this, they need to have more power in order to satisfy those requests. If you have too many services on that server to accommodate clients, they're going to run very slowly and they won't be able to meet the demand that you want. So if you think of this as a kitchen serving customers, if you have a lot of customers and you don't have very many people in the kitchen, then you're going to have issues when it comes to orders. The orders are going to come very slowly. Clients are going to be upset. Those customers are going to be upset, and they're not going to want to go to your establishment or your network because of your services running too slowly. So you want to make sure you balance your supply and your demand as well. So if you are a website that has a lot of different customers, you may have multiple web servers that can balance that with a load balancer that can balance that load, so your clients can then access those resources as well. So again, client-server networks are a relationship between clients and servers. Clients request the resources from the servers, and then the servers will provide those resources to the clients. So what are these client networks used for? So whenever you access the internet, web browsing is a client-server network. You have a web server on the internet that's provided with a static IP address and a domain, and you will go in and type that domain into your web browser, and you will go to that website. That website is servicing that page to you. You're just requesting access to it. So we'll go more into depth on how that actually works, but web browsing is part of a client-server network. Email is the same thing. When we're sending emails to people, you're sending it across different email servers. And there are email servers that will actually save that information, so that way when you access that information, they can have that information available to you. A lot of the times you have to authenticate yourself with a username and password and maybe some other types of authentication to access it, but generally email will be stored on a server that you can then access from anywhere. File sharing is another type of a client-server network, especially when we're using File Transfer Protocol, or FTP. It's where you can upload a document to a server that maybe anyone can access it, and they can then download that document to the client. Database management. Your database is essentially a server, and the client will try to grab records from that server. Social media, this is a big one. So if you have a social media account, you have your app downloaded to your smartphone, or maybe there's a website that you log into on your computer. That's the client version of that social media platform. You go on there, you scroll through your feed, and that feed is actually coming from the server that's being sent to you. There's nothing that's being saved on your actual phone or device other than that app or that web browser that you're able to access. Everything is stored on those servers. So every time you upload a picture, every time you post, it goes on that company's servers, and it's considered their property. So you want to make sure that you are being careful when sharing things on social media, because whenever you upload it from your device, it's stored on a server somewhere. And a lot of the times, these servers are stored out on the cloud. Online gaming is big too with client-server networks. You have a bunch of people that own a specific game that you load into your machine or you download into your machine, and you go access a server that's hosting that same game, and you all communicate among each other on this server. So the better your server is, the more resources it has, the more it can handle. Sometimes you can even host a server on your own network if you'd like. But again, same thing with resources. The more resources you have, the better that server is going to run. So the server is hosting that information. The clients are requesting information from that server. So what are the benefits to client-server networks? We have centralized management. We have one person. We have one person or a team of people that can specifically edit the information on that server, and the clients will then access or request those pages. We don't have to go into each individual computer and change the file. We can just do it once on the server, and they will access it. Scalability. Scalability is where if you have an increased need, it's the ability for a network to essentially improve or add devices to accommodate that need. So, for example, if you notice you have a lot of web traffic and you had one server before, that one server might not be able to accommodate all those requests, so you add another server, and you'll see whether or not investing in that separate server is worth it for the amount of views that you're accessing. So the more your network grows, the more you want to incorporate new devices to satisfy that need. And the other benefit with this is specialization. So what this means is we can dedicate servers for specific things. So I can have a separate server as a web server. I can have a separate server as a database server. I can have a separate server as a print server or a mail server. Or I can have one server that does all of those things as well. So it allows me to essentially specialize what I want with that server, and whatever those clients want, I can service those resources as much as possible. Another type of network is a peer-to-peer network or P2P network. So in this type of network, devices in a P2P network, they act as both the client and the server. So they are both sharing resources with each other, and they're taking resources from each other. Imagine it kind of like a group project where some of you take certain parts of a specific task and you share it with each other. A client-server network would be one person doing everything and sharing it with everybody else, whereas peer-to-peer, you're able to collaborate that way. And a network is great with small groups, but not so much as you scale up. Because you don't have one resource holding everything, you have a bunch of people holding, might be the same thing or different versions of those things, and you have to figure out what is the correct file or what is the useful file there. So there's no central authority or server. You are truly just sharing with each other. You want to make sure you have direct communication with all devices so you can access this information. Windows used to have a program on this called Home Group, where you'd have you join a little private network that you could put these files on, and you would have like your files on your computer. Someone else would have different files on their computer, but you could access your other computer's stuff as well. So how have we used peer-to-peer networks? File sharing is one of those examples of peer-to-peer networks, both good file sharing, like legitimate file sharing, and as well as file sharing that is not necessarily ethical, like computer piracy or things like that. Cryptocurrency is another example of a peer-to-peer network. Online gaming, this is what we call LAN. We used to do LAN parties, they used to call them, where you'd connect different computers or different consoles together without access to the internet. You would each have a copy of the game, and then you would go into a little lobby, and you would essentially game while connected to each other. As well as distributed computing, where you're sharing the information across different types of computers. So there are three main types of transmission used in networks. We can either send data to one device, one-to-one, it's called unicast. We can send information from one to all devices, that's called broadcast. And then we can also send information from one device to many devices. That's called multicast. So when unicast transmissions, the sender will send data to a specific recipient identified to by an IP address. So if I wanted to send a message to just one person that no one else can have access to, that's a unicast. So generally, web browsing, emails, file transfers, they usually utilize unicast type traffic. We want to make sure that we're just having that private connection between client and server or from host to host. So network switches, they commonly do unicast traffic. Broadcast traffic is where a sender is sending data to all devices on a network. So this is like if I were making an announcement to class, all devices or all students would hear the same information. So on a network, whenever we do a system announcement, like when DHCP rents out IP addresses and another device accepts an IP address, they will broadcast the entire network that I have selected this IP address. Multicast is where you take people that are identified by a multicast address in like a group, and then you're sending data to that group. So for example, online gaming, you are essentially join a server, you might have 8 spots in that multicast group, and then information is being sent to that group. Video conferencing is just like that as well, where if people join your video conference, your data is being sent to only those people as part of the conference, as well as IPTV as well. So let's talk about what makes your network run. So the first part of a network that every device needs to have in order to connect to not only devices on your local network, but also the internet, it's called the NIC, the Network Interface Card. So think of your NIC as the entry and exit point for your device's data. It is the only way for data to move from your device to another device in a network. It's like a translator. It converts the language your device understands into network speak that things like switches and routers can understand, and vice versa. So in order for you to connect to the internet or connect to a local network, you must have this device or capability on your device. So this allows you to connect your device to a network. It also provides the physical connection point for wired and wireless networks. So for example, if you are wired in, it's going to have the connection point for an RJ45 Ethernet cable. If you are connected on Wi-Fi, it's going to have a little antenna where you're going to be able to communicate on various frequencies over radio waves. It also translates data between your device and the network. It allows you to be able to communicate information from your device into the network. But a lot of the times NICs are built into devices, but you can also add them as expansion cards. But a lot of the times, if you're building a computer, your motherboard will have one embedded into the system. But you can also, if you want something that is a little bit more newer, has the newest standard, you can go and buy one and put it into the expansion slot in your motherboard. Another important appliance on a network is a network switch. So think of a switch like a traffic cop for your network devices. It allows you to direct incoming data to the right destination based on a unique MAC address. A MAC address is a physical address that's burned into your NIC card. It allows you to reduce congestion and ensure smooth data flow. So essentially it allows you to have unicast traffic from your device to another device, making sure it's going to the correct one. So if I wanted to send information to a specific server on my network and not another host on the network, that switch is going to allow me to route that path inside my own network. Switches only work within a local network, however. They're not used to route information unless you have this built into with a routing mechanism. So it will connect devices within a single network segment. So anything on the internal LAN, on the internal network, switches can then map devices and connect devices within that single network segment. It also learns the MAC addresses of connected devices. So if it doesn't understand or doesn't know the MAC address that it's connected to, it will ask the device itself, what is your MAC address? And then it will store that MAC address into its memory so it knows exactly who they're sending this information to. So it's just this device that knows different types of devices on your network to make sure that the data you're sending out goes to the right place. So it forwards data packets only to the intended recipient, which, unlike old hubs, it uses unicast traffic instead of broadcast traffic. It sends it to specifically what you want it to go to. And then it will also reduce collisions and improve network performance that way. So another type of appliance that makes a network work is a wireless access point. And this is specifically for wireless LANs. So a wireless access point is the invisible bridge connecting your devices to the internet without wires. It acts as a base station, so it broadcasts a Wi-Fi signal that is out there with these radio waves that your devices can then connect to, allowing you to roam freely and stay connected without being tethered to cables. So it adds that extra flexibility or mobility for users that don't want to be tethered down by that cable connected to their device. So that wireless access point, it will create a wireless network zone, and it has a specific range, and it communicates on a specific frequency, and then your wireless network interface card will match that same frequency and that same range and will connect to your wireless access point. So if you're in a room with a wireless access point and you have a Wi-Fi capable device, as long as you're in that range, you can connect to it given that you have the correct authorization and authentication, and then you can send information to anything else connected to that wireless access point. So if that wireless access point is plugged into a switch that then connects to a router, we could then send information that same path out into the internet or into another network. We can also connect wireless devices to the wired network. So a lot of the times the wireless access points are going to be physically plugged in to another type of the network, or it might be embedded into a wireless router or into a routing mechanism that will serve as a wireless router, so people can then access the internet or any sort of wired network using that as well. So wireless access points, they use radio waves to transmit and receive data. They do not use cables unless that is connected to another mechanism that would be connected elsewhere. Next, we have routers. These are the gatekeepers to different networks. So imagine a city with multiple highways connecting different neighborhoods. These routers connect different network segments like your home network to the internet. It also guides data packets to their destination using efficient routes, kind of like GPS does. So it takes your home or your organization and tries to find the network you're trying to connect to, and will establish that path between all these different routers. So as you can see in the picture, a server you're trying to connect could be on a router or could be on a network very distant from you. It could be in a completely different country or a completely different state, but it has to figure out what routers are connected to that particular server. So if you think about when you go on a road trip, say for example you're going from Tampa, Florida to Seattle, Washington. That's quite a big distance away, but you can get there. You just have to follow a specific map of roads. If you follow the correct sequence of roads that will allow you to get there in the quickest amount of time, then you'll be able to get there in a quicker amount of time than if you decided to take detours and take the slow ways around. It's the same thing with routers. They follow routing protocols, and they'll determine the best path for data travel between networks. They'll know that specific routers are faster than others, just like when you go on a road trip and you know that highways are faster than maybe 2-lane roads that have lots of traffic lights. So routers will use these routing protocols to make intelligent decisions to make sure that information is being sent quickly and efficiently from the client to the server. We can also, on these routers, especially the ones at home, we can provide security features like firewalls and access control to make sure that not just anyone is connected to that router. So all of these devices, network interface cards, switches, routers, wireless access points, as well as other network devices we're going to cover in later, they work in harmony. It's an orchestra. Each plays a specific role in managing network traffic to ensure smooth, efficient, and secure data flow. So as a network administrator, you'll notice that there's going to be some times that some of these are going to have some issues, and the whole network will come down because of one of these things. In order for a network to work efficiently, all of these have to be maintained. So network interface card, they provide the connection points. They connect your devices to the local network. The switches will manage local traffic on that network, so allowing you to connect to other devices on that network, as well as to connect to the router that would route to other networks. Routers would direct data across networks like the internet or maybe other networks on your local network. And then wireless access points provide wireless connectivity. It provides the opportunity for those devices that need mobility and flexibility to then also connect to your same network. So now we're throwing Internet of Things into the mix, or IoT. So this is where we have devices that aren't traditionally used for computing that will do different things. So for example, they might have sensors, software, other technologies to connect and exchange data with each other on the internet. So this could be, for example, your refrigerator might be able to access the internet. Your stove might be able to access the internet. Your toothbrush might be able to access the internet. Your vacuum cleaner might be able to access the internet. Things like that. They have sensors and software and technologies that allow them to do specific things. So as I said, because I have some smart products at home, I can use my phone or even my voice to be able to turn on or turn off devices. There are smart bulbs out there where you can turn on a room's lights just by clicking a button in an app or even talking to it using your voice. So actuators in IoT devices, they respond to data by performing actions. So you will tell it to turn on, and the actuator will then turn the light on. Cloud platforms that are on the internet, they'll store, manage, and analyze data collected from those devices. So they might say your light bulb is about to die and you need a new one. It will tell the app that it's doing that. If I'm doing my laundry and my laundry is finished, there's going to be a signal sent from the device to the cloud, which has my app that will tell my device, hey, your laundry's done. You need to take it out of the dryer. So those allow you to do that. The cloud platforms is just another word for internet servers, internet services. The applications will use the data from devices to then provide services and insights. So the Internet of Things is basically any device that isn't traditionally used for computing, but could be using for a lot of different things. So, for example, a PC is a little bit different than a smart light bulb or a smart stove or something like that. But these are still equally as important to secure, and they're equally important to the network, especially when you want to utilize the benefits of them. So thank you for watching. If you have any questions, feel free to send me a message or come get me in class. Have a good one. Thank you for watching.